Hi, today we'll discuss some questions in the sense problems given in module 1 of signals and systems. Let us begin. Sketch and determine the even and odd component of the following signal. Okay, so they have given that x of t is t for t greater than or equal to 0 and less than or equals to 1. So what is the meaning of that? From 0 to 1 your signal value is same as your value of t, right? From 0 to 1 your signal value is same as your value of t. If t is 0 your signal value is 0. If your t is 0 0.1 your signal value will be 0 0.1, like that. So if you draw a graph for that, when your signal value is in the sense this is your x-axis, right? This value is for x-axis, so that is this thing. From 0 to 1 your x of t is same as t. That is in the sense, if it is 0 your x of t is also 0. If it is 0 0.5 your your y-axis is also 0 0.5. If it is 1 your y-axis is also 1. Okay, you should not be confused with this basic thing. Okay, this is very simple to understand. There is nothing any magic is happening here. Okay, that is in the sense, whatever the value of t your x of t is also same. Okay, are you getting? If t is 1 your x of t is also 1. So if your t is 1, if x of t is 1, this is the point, right? If your t is 0 0.5 your x of t is 0 0.5. Since it is continuous, it can take many values in between, right? So for any value of t in this range you will get same value in the y-axis also. So this is the graph you will getting. Okay, so for 0 to 1 your x of t is same as t, so that is the reason you got this straight line. Okay, next, for 1 to 2 your value of x of t is 2 minus t. So I will explain how we got this 2 minus t. Okay, so you can observe here, from 1 to 2 what is your x of t is happening. What is the thing that is happening to your x of t? This is dropping from 1 to 0, right? Or what else you can do? T can vary from 1 to 2, right? Replace this value of t with the values 1 to 2. So if I give 1.1, what is the value of your 2 minus t? 2 minus 1.1, what is the value of that? 0.9, right? So when t is 1.1 your value of x of t is 0.9, like that. Okay, when your t value is 1.5, what is the value of 2 minus 1.5 is 0.5, right? So when your t is 1.5, 0.5 is your 2 minus t value. So you got this plot, right? You got this plot. No, there is no doubt in that. Okay, so given the value, the range will be given, right? Just take some examples, like some samples of that. You have to take the t values in between 1 to 2. So I will substitute those values in this and uh, mark the points which you got over here. You will get this what we can call the shape of your signal, right? If you if you are applying a value of t, like if you increase from 1.1 1.2 1.3 till 2, this value will be decreasing, right? So that is the reason you are getting this negative slope. Okay, so you should be very clear that if this signal is given you should be able to write this equation, and if this equation is given you should be able to write this signal. Okay, so this, I cannot say this is important only here. Okay, in module 1 it is applicable in everywhere. Okay, in throughout your signals and system course you should be able to map the given equation to a waveform and from waveform to a equations. Okay, okay, so now let us come to the problem. So uh, give me a second. Okay, now what is the question? We have to find even and odd component of the given signal. This signal is there, we have to find what is the even component of this and what is the odd component of this. So we know that we have derived this equation in the class. Xc of t is equals to x of t plus x of minus t divided by 2, right? So we know the value of x of t now, we have drew it. So x of t is this one, and what is the next thing we have to find? X of minus t. So what will happen if you write minus t over here? This is just reflection of x of t, right? X of minus t is just a reflection of x of minus t, so you will get this reflected version of this signal. So this is correct, right? So in simple sense, what you can tell, t x of t is there, they are asking us to find the x of minus t. What you can do, divide your x of t by minus 1. The coefficient of t is minus 1, right? So divide your x-axis values by minus 1. So what you will get, 0 divided by minus 1 is 0 only, and 1 divided by minus 1 is minus 1. So that is the reason you got this point, and 2 divided by minus 1 is minus 2. That is the reason you got this point. So you got these values, right? So you just have to reflect this signal, like you have to fold this signal by like this. Okay, now we found out x of t and x of minus t. So this is how you have to think. Xc of t is, they are asking for xc of t, so this is the equation for that. I have found out x of t and I have found out x minus of t. What is the next operation you have to do? You have to add the, right, x of t plus x of minus t. So when you are adding, you consider these as your time units. Okay, 0 seconds, 1 seconds, 2 seconds, or 0 milliseconds, 1 milliseconds, 2 milliseconds. That depends. Okay, that depends on the applications. In our case, we have just written its magnitude value, not its unit. Okay, so now what will happen when you add these two signals? While adding, you should have same these time stamps, otherwise it will be considered as 0, right? So x of minus t, you have to add x of minus t with x of t, right? So minus 2 plus, there is nothing for minus 2 here, right? There is a 0 for this signal at minus 2, right? So when you add this thing with this thing, like this x of minus t is defined from minus 2 to 0, and x of t is defined from 0 to 2. Remaining rest of the all is 0 here and 0 here, right? So when you add these two things, it is like when you add 1 with nothing, you will get 1 only, right? So when you add this signal with nothing, you will get this signal only, right? I will repeat, when you add 1 plus 0, you will get 1, right? In the same way, when you add this signal with nothing, you will get this signal back, right? So I am writing here x of t plus x of minus t. I have added signal from minus 2 to 0, so I got this one. There is no change because there is nothing in here. And when I add 0 to 2 with nothing, now your signal is, this is 1 now and this is 0 now, so we will get back this signal, right? So you got this signal back. Okay, so now we found out x of t plus x of minus t and we obtained this signal. So next thing is what? X of t plus x of minus t, we found out this, we have to divide it by 2, right? What will happen when you divide it by 2? What do you think will going to happen? It's just you are dividing your amplitude values divided by 2. Okay, so this 1 will become 0.5 and whatever the values here will also get reduced. Okay, there is some samples here also, right, in this value. So 0.5 is the maximum value, remaining all will be less. This is 0.9, right? 1, 0.9 somewhere here, 0.8 somewhere here, like this until 0. So now 0.5, 0.4, 0.3, like that it will reduce into 0. Okay, so be careful. Okay, when you are dividing a signal, you are dividing your amplitude value. Okay, next, similarly x naught of t is same as your what we have done here. We have to write x of t and we have to write x of minus t, and you have to subtract x of minus t from x of t. Okay, so x of t is there, x of minus t is there. When you subtract, now this is